This is the second video on volume in the series on measurement. In this video, we'll look at a reminder of what volume is, a reminder of how to convert units of volume, then we'll look at the volume of pyramids, cones, and spheres, followed by a few examples. You'll remember that from the last video on volume units, volume of prisms and cylinders, that volume is a measure of the space or cubic units occupied by a three-dimensional object, or solid. If you need further explanation on this, please refer to the volume units, volume of prisms and cylinders video. Common units for measuring volume again are cubic millimeters, cubic centimeters, and cubic meters. Volume units are simply the normal metric length cubed. You can convert between the volume using this table. If you needed to convert between kilometers cubed and meters cubed, or cubic kilometers and cubic meters, you would times by 1000 to the power of 3, or 1000 cubed. I've included this here for anyone who's watching and working on problems where they need to convert between units of volume. This was covered in more detail in the volume units, volume of prisms and cylinders video. Please have a look at that video if you need further information. A pyramid has a base that is a polygon, and its remaining faces are triangles that meet at the apex. A cone is a solid with a circular base and a curved surface that reaches from base to a point called the apex. The volume of a cone or a pyramid is a certain fraction of the volume of a prism or cylinder with the same base area. Here you'll notice that I've drawn a prism over the pyramid and a cylinder over the cone with the same base and height. If you had a paper pyramid and filled it with water, it would take 3 of the paper pyramids to fill up a prism with the same base area and perpendicular height. Therefore, the volume of 3 pyramids is equal to the volume of a prism with the same base and height. If you had a paper cone and filled it with water, it would take 3 of the paper cones to fill up a cylinder with the same base area and perpendicular height. Therefore, the volume of 3 cones is equal to the volume of 1 cylinder with the same base area and height. In this regard, the formula for the volume of a pyramid and a cone is given by 1/3 of the area of the base times the height, which is given here as volume is 1/3 capital A times height, where A is the area of the base. Let's look at an example. Here we have a volume, we're going to calculate the volume of a pyramid with a square base. So the volume is 1/3 A, which is area of the base, times the perpendicular height, H. In this case, we've got a square base, and we know the formula for the area of a square is length squared, or 10 is going to be 10 squared. Therefore, 1/3 length squared times height, and we get 1/3 10 squared times 15. And then we evaluate, and we get the volume of this square base pyramid is 500 meters cubed. Now we have another pyramid with a triangular base. We're going to calculate 1/3 area of the base times the height. And we've got some measurements. And this time, our base is a triangle, therefore we have to use the formula for the area of a triangle, which is a half base times height. And this is an equilateral triangle, which says that all the sides are the same length. And we're given the height, or in this case, the height of the base triangle if you're looking at it in 2 dimensions. And we substitute in our known values, and we evaluate, and we get the volume of this triangular base pyramid is 175 meters cubed. Let's look at the volume of the cone. It's going to be 1/3 area of the base times the height. And in this case, we're given the radius of the circle on the base is 10 millimeters. The height is 15 millimeters. So the area of the base is going to be the area of a circle, which is pi r squared. And we substitute in our known values, and we evaluate, and we get the volume is 500 pi millimeters cubed, which comes to 1570.8 millimeters cubed. A sphere is a round solid with every point on its surface equidistant from its center. Remember, spheres are perfectly symmetrical. They have no edges or vertices. They have one surface, not a face, as it isn't flat, and they're not a polyhedron. The volume for a sphere depends on its radius r and is given by 4 on 3 pi r cubed, where r is the length of the radius. If you ever go on to study calculus, you'll more than likely learn the proof for the formula for the volume of a sphere, but it's beyond the scope of this video. Remember that if you're given the diameter of a sphere, you're going to need to halve it to find the radius to calculate the volume. Let's look at an example. Here we state the formula. Volume of a sphere is 4 on 3 pi r cubed, where r is the length of the radius. Now we give an example with measurement, and we substitute an unknown value, and we can evaluate, and we get volume is 36,000 pi centimeters cubed, which comes to 113 and 97.34 centimeters cubed. Let's look at the volume of a composite solid. The volume of a composite solid is given by the sum of the volume of all of the more basic shapes or solids that make it up. In this case, we've got the volume of the composite shape is the volume of the rectangular prism plus the volume of the square base pyramid. Here we have some measurements. Now we know the volume of the composite shape is going to be the volume of the rectangular prism given by length by width by height plus the volume of the square base pyramid, which is going to be 1/3 the area of the base times the height. This time we've indicated height with a capital H to differentiate it from height in the formula for the area of the rectangular prism. Now we can substitute in our known values and we can evaluate, and we're going to get the volume of this composite solid is 53.33 meters cubed. In the future videos we're going to be looking at capacity, volume, capacity, connection and capacity. Thank you.